We will now discuss the solution of a problem from the section Mathematical Reasoning. In this problem, you are asked to find an equivalent Boolean expression of a given Boolean expression. In this question has appeared in the joint entrance exam main held on 27th June 2022 in the first shift. The given question is the Boolean expression negation of P and Q in brackets RQ is equivalent to. We are given four options. Option A, Q implies P and Q. Option B, P implies Q. Option C, P implies P and Q. Option D, P implies P or Q. We are given this Boolean expression and we have to find out that Boolean expression from these four options which is logically equivalent to this Boolean expression. That is the given question to us. Let's now discuss the solution of the problem in detail. We take the given Boolean expression, that is negation of P and Q in brackets RQ is logically equivalent to. We apply negation of P and Q. For that, the De Morgan's law. What the De Morgan's law says? Negation of P and Q is negation of P or negation of Q or Q. This is logically equivalent to this one. Agreed? Now, we associate negation of Q with Q. So, we apply associative law. That is logically equivalent to negation of P or, in brackets, negation of Q or Q. And we know for any statement, negation of Q or Q is a tautology, means to say that it will give you always the truth value T for all truth values of Q. And negation of Q or Q is logically equivalent to T. That is, it is always true, it is a tautology. This is logically equivalent to negation of P or T. And it is known to us for any statement P, R T will be T only. So also for negation of P also. So it is logically equivalent to T. That means for all truth values of P and Q, this Boolean expression will give the truth value true always. Therefore, this is a tautology. And we want to find that Boolean expression from these four options which is logically equivalent to this given Boolean expression. But this given Boolean expression is a tautology. Therefore, we have to find out that Boolean expression from among these four options, which one is a tautology. The Boolean expression equivalent to this given Boolean expression must also be a tautology. We will now find which of the Boolean expressions given in options A to D is a tautology. That we discuss in the next slide. So that's what we have done so far. Agreed. Let us take the option A. Option A says Q implies P and Q. Now apply the logical equivalence given by P implies Q is logically equivalent to negation of P or Q. So this will give you, this is logically equivalent to negation of Q or P and Q. Agreed. Now we use distributive law. So we use distributive law. The distributive law says is logically equivalent to negation of Q or P, yes, and negation of Q or Q. Agreed. Negation of Q or Q is a tautology. So it is logically equivalent to negation of Q or P and T. And we know for any statement P and T, it will give you is logically equivalent to P only. So in this case, is logically equivalent to negation of Q or P. Agreed. Suppose we take P truth value false, for Q truth value true, then the negation of Q will be false or false is false. So this will return the truth value false when P is false and Q is true. Therefore, it is not giving rise to the truth value T for all truth values of P and Q. Therefore, it is not a tautology. When it is not a tautology, this is not, the Boolean expression, given Boolean expression is not equivalent to this Boolean expression given in A. Yes. So the option A is ruled out. Now call option B. Right. Option B. P implies Q. And you know, it's logically equivalent to negation of P or Q. You apply this formula. Right. And now its truth value is the false when P is true, Q is false. When P is true, negation of P is false. False or false is false. So it is not a tautology. When it is not a tautology, the given Boolean expression is not equivalent to this one. So we have also ruled out option B. We take option C. So option C is P implies P and Q. Look at A. You just interchange the P and Q. You will get, if you interchange P and Q in A, you will get C. In the case of A, there is logically equivalent to negation of Q or P. Therefore, in this case, it will be is equivalent to negation of P or Q. Just interchange P and Q. Agreed. As above, it will give rise, its truth value is F when P is true and Q is false. Therefore, this is not a tautology. When this is not a tautology, the given Boolean expression is not equivalent to the Boolean expression that is given in option C. Therefore, we have ruled out A, B, C. Therefore, obviously, the answer is D. That means the given Boolean expression is equivalent to the Boolean expression that is given in option D. That we will see in the next slide. Agreed. Okay. We have ruled out A, B, C. Now let's take D. P implies P or Q. So apply P implies Q is logically equivalent to negation of P or Q. So this will be equivalent to negation of P or Q. Agreed. Apply associative law. So it will be logically equivalent to negation of P or Q. Agreed. Associative law. Negation of P or P is a tautology. This is T or Q. And T or any statement will be T only. It's logically equivalent to T. That means it is returning the truth value true for all truth values of P and Q. Therefore, it is a tautology. When it is a tautology, the given expression is also a tautology. Therefore, they are equivalent. The given Boolean expression is equivalent to the Boolean expression given in option D because they are both tautologies. So, the answer to this question is the option D. That means that the given Boolean expression is logically equivalent to the Boolean expression that is given in option D. So, that is the detailed discussion of the solution of the problem on equivalence of Boolean expressions from the section mathematical reasoning, and this will be definitely be an interesting question. Agreed? So, I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.